Hello everyone, in this video we talk about profit maximization. As we know, every firm, whether big or small, has one main goal, which is maximizing profit by finding the right balance between production and cost. And the golden rule for profit maximization is that the firm keeps producing until marginal cost MC equals marginal revenue, the MR. So MR, actually the marginal revenue here is how much extra revenue we get from selling one more unit, and the marginal cost here is how much extra cost this additional unit adds to the total product. So the condition here is if the marginal revenue is greater than marginal cost, this means producing more increases profit. In the other case, where marginal revenue is less than the marginal cost, here it means producing more decreases profit. Let's see an example. Suppose producing 10 units, producing 10 units gives a total profit of $100 for a company. This is the profit that the company makes by selling 10 units. And now see here, if the company produce one more unit, number 11. If the company now produce one more unit, the marginal cost is 25, which means this 11th unit costs $25. This is the marginal cost, and the marginal revenue is $20, which means selling this new or this additional unit will provide $20 as revenue. Now this means producing additional unit, by selling it you get $20, and this additional unit costs you $25. 20 minus 25, it will be minus $5. So the firm will lose $5 for the additional unit, meaning that the total profit becomes 100 minus 5 becomes $95 instead of $100, which means here the firm decreased its profit from $100 to $95 because they produced additional units while the marginal revenue is less than the marginal cost. Now let's see the second case. Another case here, imagine that the marginal cost, which means the cost of the additional unit, is only 15, and the here the firm sells the product at $20, which means 20 minus 15, 20 which is the revenue minus 15 which is the cost, equals $5. So the firm will make additional $5 profit from the additional unit sold here. So which means the total profit after selling the 11th unit will become $105 instead of $100, which means the firm can still make more profit. Here the firm is increasing, actually not this, but here the firm is increasing its profits by producing more units. So the firm here will keep producing until producing more doesn't add anything. So the condition when the marginal cost equals marginal revenue, the firm neither gains nor loses from producing the extra unit. So the profit is maximized at this point when MC equals MR. So producing more will reduce profit. Producing less would miss out on profit, which means the optimal or the profit maximization happens here when the marginal cost equals the marginal revenue. And there is something specifically for the perfect computation market, where the marginal revenue in perfect computation marginal revenue equals the price, because the price is constant for the perfect computation. As we said, they have no control over the price, which means P is constant whatever the quantity. So marginal revenue is the price. So the firm maximizes profit where, instead of saying where MC equals marginal revenue, we can say when MC equals P, since in perfect computation the marginal revenue equals the price. Now let's build a clear example to illustrate profit maximization in perfect information market. Imagine a firm in a perfectly competitive market has this cost function here. TC equals Q to the power of 3 minus 6Q squared plus 20Q plus 10, and the price is 20. The question is find profit maximization. So the first thing here to do is, we know that in perfect computation we know marginal revenue is the same as price. So the condition here for profit maximization is when MC equals the price, and then we can find the marginal cost MC. We know that the marginal cost is simply derivative of total cost with respect to the quantity, which means MC equals the derivative of total cost with respect to the quantity, which is 3 here, 3 times Q to the power of 3 minus 2, which is 3Q squared minus 12Q plus 20. And we set this equals to the price, so this equals P, which is 20. Then we will get this. So 3Q squared minus 12Q is 0, and then we can by factoring it we will get this 3Q times Q minus 4 equals 0. Then we have two solutions, either Q equals 0, which doesn't make sense in production, or Q equals 4. So the solution here, the profit maximization happens when the quantity produced is 4. So to find the value of this profit, we replace Q equals 4. As we know, profit actually is TC minus TR minus TC, total revenue minus total cost. So we replace 4 here in the total cost function. We will get this 58. Then we will get the total revenue, which is price times quantity. So total revenue equals price times quantity, which is 20, the price times quantity, which is 4. We'll get 80. So profit maximization is 80 minus 52. Here we have 52. We will get the value of 22. The maximum profit that the firm can get in this case is 22 units. Or we can also find the solution using the table like this. So here we have the different quantities from 1 to 6. Then here we have the fixed cost, which is this part. Then we have which is 10. It is fixed for all quantities. Then we have VC, which is variable cost. Variable costs are this part. Is the cost that depends on the quantity, or the total cost minus the fixed cost. So VC is this part. Okay. So we replace, for example, here Q is 1. If we replace 1 here, Q by 1, we will get 15. If we replace Q by 4 here, we will get 48, and so on. TC also can replace the value of Q in this function, all this, or we can just simply make it FC plus VC. This is the TC. Then we have here MC, marginal cost. And marginal cost, you can use the marginal function, marginal cost function, which is derivative of TC over with respect to Q, as we found it here. This is the MC function. We replace Q by its value in this function to find all those values for each quantity, and then which means here when Q is 2, for example, we replace 2, we replace Q by 2 in this function, so we'll find there's values of marginal cost. Then we have total revenue, which is Q times P. P is 20, it is constant, times Q, so 20 times 1, and here it is 20 times 2. Here, for example, 20 times 5, we will get 100. Then profit is simply profit is the total revenue minus the total cost. This minus this. So 20 minus 25, it is minus 5. 40 minus 34, it is 6, and so on. This way we get all the value of profit for each produced quantity. Here, if we check to find the highest production level for if the quantity is limited to 6, we will find 22. Okay, and now we will see the shutdown point. You have to know that in the short run, a firm must at least cover its variable cost, VC, to stay in business. So if the price falls below the minimum AVC, average variable cost, the firm cannot even pay for its day-to-day operations. So it's better to shut down temporarily. And the shutdown decision depends on comparing AR, which is the average revenue, and average variable cost. And in perfect computation, the average revenue is equals the price. It is the same as the price. So here the condition is if the price is greater than AVC, the firm should stay open, which means when you sell, you can cover your average variable cost. You cover your variable cost. But here, when the price is less than AVC, it means when you sell your product, you cannot even cover your variable cost. Here, this should the firm should shut down. Here, when the price equals the AVC, here the firm can stay open or shut down. It's called the indifference point. Therefore, the shutdown price actually is when AVC it is at its minimum. At this price, there is no quantity that the firm can produce and cover its variable costs, which leads to shut down the business. We'll see the same example as for profit maximization. Imagine we have this firm that have this total cost function. The price here is 20. Let's find the shutdown price. Here actually price is not important, okay? So because we are looking for the shutdown price. Here, how to find the shutdown price? Simply first we need to find VC. We know that VC is the part of TC that depends on the quantity. AVC is simply AVC is VC over quantity, which means VC over Q. We will find this. Then we will find the average variable cost minimum. The minimum of this AVC is so we will get it when the derivative of AVC with the respect to Q equals 0. So we set this equals 0. The derivative of this with respect to Q, we set it equals 0. And the derivative of this is 2Q minus 6 equals 0, which means Q equals 3. So the minimum average variable cost happens when Q equals 3. And we have here AVC mean we replace Q equals 3 in this function here, in this equation, and we will find 11. So 11 is the minimum average variable cost, and this is the shutdown price, which means if the price equals, if the price is less or less than 11, okay, if the price is less than 11, there is no quantity that allows the firm to cover at least its variable cost, which means the price should be greater or equal to this price, shutdown price, which is 11. And let's check it in a table. So here we have a table for, we have FC for each quantity, which is constant, VC, TC, MC. Then we have to find AVC. This one is important, which is AVC equals VC over quantity. We will find AVC here, then ATC, TR, profit. Let's check here the minimum that AVC can have is 11, and this happens when the quantity is 3. So the shutdown price here, shutdown price is when AVC is minimum, which is 11, and this is the shutdown price. And that's all for this section. I wish you good luck and thank you for watching.